Hello and welcome to my geeky hobby channel for another episode of fighting with Arduino Nano Clones. So today we are going to try and fix yet another type of problem that I'm facing quite often, and this is an upload problem, sketch upload problem. So I'll try to show you the issue, and I'll try to show you what I'm doing to fix it, and we'll fix it together. So before I dig into actual fixing, let me actually explain what the problem is. So what we have here is a sketch of my EEPROM emulator, ready to be uploaded to a Arduino Nano, and let's show you the module. So just a standard, clone, Arduino Nano clone. Nothing looks like it's broken, so it should work fine. But let's hit the upload. So hit the upload, and we'll see that we are actually sending stuff to the Arduino Nano. So you can see the computer is sending something, communicating with it, but we get this error message. Okay, so let's have a look what sort of error message that is. So the communication between the computer and the Arduino Nano sort of worked, so we can see it got synchronized. We see here that the computer knows it is a 328P based Arduino, and it actually starts writing to the flash of the Arduino, starts writing the code. But then when it wants to read it to confirm that the writing was successful, it's it's having problems, and we're getting this protocol error, programmer out of sync issue, read operation not supported for memory flash, blah blah blah, things like this. So something has obviously gone wrong. So what has gone wrong? What the issue is. So let me just clear the output here, and I'll reset this Arduino, and I'll explain what's happening and what I believe the problem is. So you can see on the screen that in the serial monitor output, some of the characters or some of the message looks corrupted. There's some kind of unreadable or undisplayable messages coming out of the Arduino to the computer. And of course, this is probably messing up the programming as well. Not just the messages coming from the normal operation of the Arduino Nano, but also during programming, this is likely also happening, which is breaking the whole process. Now, Arduino is not a very sophisticated piece of equipment, we all know. So here is a diagram of Arduino Nano. Let me just bring just a diagram. So we know there are two chips inside the Arduino Nano. That we have the main processor, which is the Atmega 328, which is on the left-hand side, and here in the middle is that CH340 chip. This one is responsible for converting the traffic from the USB port, so the transmission between the computer over the USB protocol, into a TTL, just to receive and transmit signals. And they ultimately end up inside the processor. So what the suspicion in this case is that as the communication is coming out of the microcontroller, out of the 328P, it's supposed to be reaching this CH340 and properly being converted and sent over USB into the computer. Something is likely happening to that signal. It's probably of course I suspect, and I confirm by practice with other Arduino Nanos that I was dealing with, that this CH340 is broken and it's messing up this communication. So how can we confirm, before we start trying to fix that CH340, how we can confirm that this is indeed the problem? Well, what we can do is we can attach to our computer a secondary USB to TTL adapter and hook ourselves into the same signal out of the processor and look at both of them and compare, you know, are we seeing the same issue on both or not? This will confirm that it's actually the CH340 converter chip that is the, you know, the culprit here, and that's what's breaking the communication. So let's do exactly that. Let me take you to the desk. So what we have here is just a standard FTDI-based converter, TTL to, I mean USB to TTL, and we are only going to use the two signals, ground and the receive pin. So ground will tap into the second pin here, and we'll plug ourselves into the transmit pin. So on this side of the Arduino, I've got the transmit pin of the serial port. So that's this pin here. And on the other side, I'm just tapping myself into the ground, the GND signal. So those, you know, with this plugged in, we now have two sources of the same information. So the Arduino, the AdMega chip is sending this transmission towards this blue USB port with its built-in CH340 converter, but we are also taking the same transmit signal onto this second converter. So I'm doing this all just to kind of prove that it's that CH340 that is broken. So let's go back to the screen, and what I'll do here, just a reminder what we've done. We have this USB to TTL adapter. We're looking at the same transmit signal out of the microcontroller, and we are watching that signal, of course, on the built-in Arduino serial monitor, but I'll also bring this second copy of that signal coming from this second converter. So clear the output here, and what I'll do is I will reset the controller again. And this time we actually haven't seen any mess up on the screen, so that's fine. Let's try again. Clear. I'll reset once again. The output looks clean. Okay, let's reset once again. And you can see straight away that we've just hit the same problem. So see at the top there, just under this hardware version 1.9, we have the config line, and it's supposed to just read last EEPROM blah blah blah. So we see this got messed up again. We have those question marks or those characters that we are unable to display correctly. There's some more here as well. But on our second copy, you know, on our other TTL to USB converter, we don't see those messed up characters. So that kind of confirms that that the problem is indeed that CH340 that is built into this Arduino that is causing the problem. So I've seen it before. I've replaced quite a few of those CH340 chips, because occasionally I come across exactly this this problem. So let's try to fix our Arduino by transplanting that CH340 chip. So at the bottom of this Arduino we have the CH340 chip that is responsible for the serial transmission, and in our Arduino we believe that chip is completely broken. So what we need to do is desolder the broken one and resolder a working replacement. Because this chip is definitely dead and causing trouble, I'm not going to care about this chip. I'm going to just try to get it out of this circuit, you know, by simply cutting it out of this PCB, hopefully without breaking the PCB itself. I've got an X-Acto knife, and now just leg after leg, or one lead at a time, I'll try to cut this chip out. Okay, so I think I've got one side out. I should be able to lift this chip now, and I can probably wiggle it a bit, and this will allow me to pretty much break this chip out. So I could use a hot air gun maybe and desolder it this way, but I found this to be an easy way to eliminate the chip from the PCB. Let me mount it in my holder. I've got this 3D printed holder for the PCB. So you know, the old legs of that chip are still on the PCB, so we need to clean up a little bit. I would say we'll add a little bit of flux, as recommended by Louis Rossmann. And we'll try to just add some fresh solder, and all those broken legs will end up on our soldering iron. And then I can clean the tip of the soldering iron, getting rid of those legs. And we'll add again some more. Some more fresh solder, and that will give us a relatively clean area to work with. Let me think. Yeah, I think that should be good enough. So what we can do now is grab a new CH340. I'll put a link in the description. I bought a set of 5 on AliExpress, and I already used 2. So I already fixed 2 other Arduinos using this method, so I know this is definitely the issue. Watch out for the orientation of the chip. Obviously, there's a small dot here on the silk screen that indicates which way this chip should be soldered. It's kind of small, but you know, with a bit of flux and patience, you should be able to install it relatively easy, he said. I will typically take the approach of trying to solder just one of the leads of the chip to give it a bit of stability. Sort of this way. And then we'll do another one on this side. Yeah, and then we can do a bit of drag soldering. Adding a little bit extra solder in between. Okay. And the pins at the top. yeah, that should be fine. Let's put some IPA alcohol there and clean it with anti-static brush, just so that we can inspect the solder joints a little bit better. Okay, let's take a look. I'm gonna zoom in a little bit more. Yeah, to me they look okay, which means we can take this and plug it in and test it. So let's zoom out a bit, clean up our desk. Where is our cable? Okay, let's try to go to our Arduino IDE and upload the sketch. So let me bring you back to the screen. Okay, so we're back at the IDE. Let's see if we can get our Arduino updated this time. And as you can see, this time we haven't had all those issues. So let's start the serial monitor. And you see that the errors that we were getting, the corrupted characters, are not there anymore. I mean, I can restart this Arduino Nano once again. And as you can see, the output is exactly what it needs to be. And of course, the most important thing, we were able to this time upload this sketch successfully without any errors. So that kind of concludes the video and concludes our efforts fixing this Nano. It might not always be worth your time and effort fixing it. Of course, you need those CH340 chips to actually perform this transplant. So maybe if you just only play around with one Arduino and you don't think you're going to be doing it in the future, it's not really worth it. But if you know that this happened before, and if you quite often use those Nanos, it might be worth just purchasing a set of those CH340s for the situation where you have to repair one of those Nanos. They are becoming more and more expensive because of the shortage of the chips. So suddenly it's worth occasionally to try and repair those modules. Anyway, thank you very much for joining me tonight, and I'll see you on the next one. Bye.